Hello everyone, welcome to the another session on Python. So yesterday we covered the two collection types of Python. One was list, the other was tuple. But yesterday I realized that the video was quite long and quite heavy. So let's just keep it simple and keep it only till one part, which is sets. So a set object is an unordered collection of distinct hashable object. Before I take you there, I see there is a problem. Let me just update this as well. What I see is when we are talking about the list item, how did we create the list? With the square bracket. Then we talked about the tuples, and the tuples were created with the circular bracket. Let's go to our sets, and the sets are declared with the curly bracket. So again, the same functions that we'll be using here as well, and some kind of a set functions as well. So len s gives you the head, it gives you the length of the set. X in S is if one set is in S, or in another set, or might be some values which we are finding. X not in S, so we are checking again the same thing, whether the value that we are finding is not in S, so that will give us true. If it is there, then it will return us false. S is subset of T, so we are checking that whether S is a subset of T. S is superset of T, whether T is a subset of S. S dot union, where we'll be getting the values of both S and T. Intersection, we'll be getting the common values that we have between S and T. S difference T, S difference T will show us the element which are there in the S but not in T. And symmetric differences T would be doing the same thing that we were doing for differences, but this will show you the elements which are there in both of them but not in both. So it will remove the common values but show you the values which are either in S or either in T. And then the copy method just does the shallow copy for you. So we saw that example in the list part as well yesterday, where we were creating a shallow copy, and when we changed the value in any of the copy of the original copy or the copied copy of the list, the updates were not going in. So these are all the theory part or the type of operators we were discussing. So let's just move over to working on set. So this is how a set is let me just run it. This is how a set is declared. And then what I'm writing down is print in type of set. So this is gonna give you the type of the set, and then when I say set consists of :set, it will give you all the values that it consists of. So let's just see the output of these 4 lines, which can be seen from here. So the type of set is class set, and set consists of 1, 2, 3, 4, 5, and 6 values. Yeah, I was feeling one more thing, that there are a lot of codes that we are checking there, and we are not able to check the output at the same time. So what I'm planning to do is I'm planning to in the call itself, let's just do one thing. We divide our code into smaller subcodes, and then I think it would be easier. Yeah, so I'm sorry I'm taking a longer time here to do this. So let me very quickly copy the content, and here let me add a code. and put in that value here. And then we will run each section. For example, here we were talking about the set, so this is how we declare the set. I add another code, and let's just talk about the length of it. So we can see that the length is 6 for the set, which is 1 2 3 4 5 6. Then let's just remove the spot and then check the method whether x is in s or not. So very quickly I'll put in here and run it. So x is in x in s, so 5 in this value is true, whereas 7 in this value is false. Now you see that in is attached to the curly bracket. The only reason is because we don't have a space here. So if I, after giving the space, I run it again, you will see that there is a space. And str set and str5 in set is because if we concatenate string to anything, it will give us an error. So we are converting everything into string. So I'll just add another code where we'll be talking about x not in s. So I'll just place it here, and yeah, that issue is not there here. So x not in s, so 5 is in in the set, so that's false, and 7 is not in the set, so that is true, is not. The next part is where we are checking the subset. So we have print ns is subset t, set all is 1 2 3 4 1 3 5, 1 2 3 is 1 2 3. Then is print str st odd subset of str set, which is the value of 1 2 3 4 5 6. It should return us true. So I'll just run this. The first one returns us true because 1 3 5 isn't consistent in it. And when I say 1 2 3 subset of this, it gives me a true because the value of set 1 2 3 also is there in the set. Then I check for odd is a subset of set odd. That set is a subset, so that would be false. And is set of set 1 2 3, that will also give me a false because the value of the set does not belong in the subset. In the set odd or set 1 2 3, had all the values been there, then the result would have been true. So the next thing that we are talking about is the superset. Superset is again just the opposite of subset. So earlier when we were getting true, this time it will be giving us false. So you see that this is a superset of this, which is false. This is a superset of this, which is false, which we are checking here. The value of true and false is coming from here. But if we see this is a superset of 1 3 5 true, if this is a superset of 1 2 3, that is true as well. Now the next thing is we have two lists, right? So we have the set even and set odd, and then what we are trying to do is union for them. So earlier set even was 2 4 6, set odd was 1 3 5, but when I union them, I see that we have a set which is having all the values of the two union items. So I'll just get rid of it. Then we will be talking about intersect. So intersection. So what we are talking about is odd and even. When they try to intersect, I think there is no value in it. So what will happen is, if there is no value, it will not show you any value. So let's just run this, and then I'll keep on adding the other examples. So this is the first example. So set is empty. Now what I'm doing is I am doing the same thing of intercept with the set odd with the set. So it should only show me all the values which are there in the set odd. So set odd is 135 and so is the set intersection odd. We will be doing the same thing for even as well. So this is the third example that we have, and you will see that the values of the even will only be shown now. So this intersection set shows 246. This time I'll pick up all the three examples of differences, open up another code and write it down there and hit enter. So we see that the difference between set even and odd is 246 because it will be having all the values which is there in the set even which are not there in the set odd. Similarly, when we are doing it for set and set odd, so set the difference would have only the even values because odd values have been removed from set. The next is set and set even, so it will give me all the odd values because even values have been removed from there. Then the next example that we are talking about is the symmetric description. Sorry, what I was saying. Not symmetric dimension, but symmetric differences. So let me just pick this up, create another code, place it there, and run it. So now what we are going to see is it will show you all the values which are there in the set even and which is there in the set, except the values which are common in them. So it doesn't show me 2 here because that's common in both the places. It doesn't show me 4 because that's common, and it doesn't show me 6. Except that it shows me all the other values which are not common. Next is very important example. It's an example of copies. So we are just saying that net var set even is equal to net set even. So we are putting all the even values in the new var set, and then we are adding one value 14 to the new var set, and we are going to print even. So let's see what happens, because we have not added the value of 14 in the new set even, but we have added it in the new var set even. So let's just run it. You will see when we make the copy and we make the change, yeah, we make the change into new var set, but we see the difference or the updated value in the other part there where we are just showing it. So this is where we are just putting in the variable there. So that creates, because the value is, we are assigning it to it, so both the objects or both the variables are pointing to the same container. When we say new var set even or new set even, they are both pointing to the same container. So irrespective of religion, when you try to pray, you pray to the same God, and that's what it is doing here as well. Might be my example is not correct in the case of the God, but then let's just take a very simple example that you might call a guava with a different name at different places, but it gives you the same satisfaction everywhere or the same taste everywhere. So that is what we are talking about here. So you can call guava anything, but you're asking for a guava anyways. So that is what is happening here. We have one variable which had the values and we have assigned it to the new variable. Both of them are pointing to the same object that we have. But if you don't want this kind of the settings, so what you can do is you can create a new set even copy, which is coming from new set copy, and then I add value 16 and 18 to the new set even copy, and then we will see if I run the code, what is the value in the new set even copy and what is there in the new set. So you can see new set even copy is having a value with 16 and 18, and new set even doesn't have the value of 16 and 18. So that is how this is working, as in how this set copy method is working. So with that, I think we have come to the end of this session as well. So I hope we have moved a bit forward in our learning, and looking forward to continue this journey. So thank you for your time and good day. Bye bye.